So quickly, can I invite the chairperson for this session, Dr. Olufemi Olarewaju, to come take up his position. And then next, we would like to invite Mr. David Picard, president of Clearstone Engineering. He's going to be the lead speaker on GHG measurement, discussing various techniques. And of course, to join them is engineer Jennis Anyanwu. I met him earlier on, assistant director for gas production and utilization, NUPRC. A spotlight speaker on the topic accounting for gas production to minimize greenhouse gas emissions and maximize value. And certainly it's great to know that we also have a speaker who is going to help us with the topic enhancing flare gas combustion efficiency, a crucial step towards environmental sustainability. And that is engineer Oladapo Ojo, the executive director for strategies of DAPEM Engineering. And finally, we have my very good friend, engineer Femi Adefala, maintenance coordinator for Aradel Holdings, one of our major sponsors for the 2023 edition of NIMEC. We'll say a big thank you to every single one of you for your patience. I'm very sure this session is just going to go steadily, as quickly, but necessarily not compromising with the content. I know Dr. Femi is fully in charge of this session. Can we have engineer Ojo?
So we also have Ken.
Yeah, and do we have one more person?
Yes, we do.
Okay, so I don't have that on this list.
Uwalaka.
Dr. Ken?
Dr. Ken?
All right. So over to you, sir. The engineer Joe is joining on there. Please come up, we've called you, so that we have a complete session. Thank you very much, Dr. Femi.
Yeah, thank you so very much. Good afternoon again, everybody. It's been nice seeing the level of participation. So we'll try and make this as interesting as possible and close it out as quickly as possible. Well, I've been asked to invite everybody to kind of move forward a little to fill up the empty spaces. Please. Thank you very much. So a quick one, by show of hand, if you are not trained as an engineer, you are not an engineer, you have not received engineering training, you did not work as an engineer, can you please raise your hand? You said you're a chemical engineer before you became an MC, so you don't count. Unaccounted. So it's only about 4 people. So we have a room full of engineers, so you're right, Chairman. We need commercial, we need legal, we need policy heads, because yes, this is an engineering conference, but what we are producing is a product that is going to be consumed mostly by non-engineers. Those that are going to make the decisions of where these things are going have to be able to understand them. I just wanted to get that going. So quickly, by way of introduction for this session, I'll talk about certain key areas that we've already touched on briefly. So for Nigeria, gas is a transition fuel. We are very, very clear on that. That means that we have to increase its production, and for the purpose of development, we have to increase its consumption. And part of the areas that we're looking to do those is in power and industry. So here, as technical people and engineers, it's clear to us already the business that we do. We're in the business of technology, we're in the business of automation, we're in the business of making things happen, so it's good. But what the current global system is telling us is that we also now have to start thinking about how we do that business. It's no longer simply about the business we do. It's also how we do the business. How does our product assist in moving a system forward where we now have to pay attention to social and environmental stewardship? And this is the essence of where you have things like greenhouse gas emission, things like energy transition, things like climate change. So these are real. In fact, Nigeria has published its energy transition plan, and it targets carbon neutrality by 2060. These are serious level policy directions, and they're looking at areas of power, cooking, transport, oil and gas, and industry as areas where we have to find ways to reduce greenhouse gas emissions. So this is just the background to this. We're going to have 5 people present for us now. We're still going to talk about these different technologies, how they can impact greenhouse gas emissions. But my hope is that at the end of the day, we'll be able to have regular conversations that speaks more to what possible solutions can be. Even if we don't have all the answers here today, as the committee members, at least we can get an idea of what direction these things can be so that we can start making sure that we include them in our processes. So without wasting too much time, I'm going to invite David Picard, who is the president of Clearstone Engineering. He's going to be speaking on greenhouse gas measurements and discussing the various techniques. Mr. Picard, ladies and gentlemen, please give him a round of applause.
Thank you very much. It's a pleasure to be here. And I guess it's an honor to be in the last run of speakers here. Anyways, my presentation is on greenhouse gas measurement. And greenhouse gas measurement really comprises a number of things. There's various standards and regulations that relate to measurements. There's different measuring and monitoring technologies that get applied. And really, it depends on the circumstances and the sources you're looking at and the types of gases that you're interested in. In terms of my profile, I've worked in the oil and gas industry my entire career. I started off in operations and transitioned into facilities design, construction management, and commissioning. But ultimately, I became involved in emissions management at facilities. And most of my career has really been involved in that area. I've worked at a high level in developing methodology manuals that are being used by industry. In North America, I was involved in the IPCC guideline development. And at a low level, I've been involved in measuring emissions for the purpose of developing emission factors, for identifying opportunities to mitigate emissions and to provide confirmation of emission reductions that are being actually achieved. In terms of the relevant standards that really, the key greenhouse gases that relate to the oil and gas sector are carbon dioxide, nitrous oxide, and methane. The assessment of carbon dioxide emissions is reasonably straightforward. You're looking at the carbon content of the gases that are being burned, and you're applying conversion factors of that carbon to CO2, and you're multiplying that times appropriate activity values. So typically, you're looking at the fuel consumption, you're looking at flared volumes, and to some extent, if there's a lot of CO2 in the gas and you're sweetening that gas to remove it, then there's a concern about the amount of raw CO2 that is coming from the formation that is ultimately being released into the atmosphere. To a much lesser extent, there is a potential for CO2 to come from vented sources and fugitive emissions because it's a natural constituent of the gas, but normally it's a very small contribution and often is treated as being de minimis. But the measurement systems that you've been discussing over the last few days all really relate to that type of activity. It's fairly straightforward. If you are measuring your flared volume, you're measuring your fuel consumption, then the rest of it is fairly easy to do. Nitrous oxide emissions, they're not a particularly significant contributor to total greenhouse gas emissions from the oil and gas sector. They get treated as a co-pollutant of the flaring and fuel combustion activities that might take place, and normal practice is simply to apply an emission factor to those activity values and not actually measure it. The bigger concern, and the one that's most challenging, is methane emissions. Methane emissions come from a variety of sources, and it's a powerful, short-lived greenhouse gas pollutant. It's the one that's getting a lot of the global attention right now. So that's where a lot of the more difficult or challenging issues in terms of trying to quantify those emissions arise. So one of the key standards that currently exists that relates to methane emissions in the oil and gas sector is the Oil and Gas Methane Partnership measurement or monitoring framework that's been, measurement-based international reporting framework that's been developed. And that framework has 5 different levels of reporting that can be done. The lowest level of reporting is basically using default emission factors to fairly high-level activity values, and there's very little disaggregation of the emissions, but that's kind of an entry-level point to get into the program. The other end of the spectrum is actually doing measurements to determine emission contributions from individual sources, and as well, not just measuring emissions from sources, but actually doing supplemental verification measurements to confirm that your results are complete and are reliable. And in that program, in terms of methane contributions, the program identifies 13 different sources of methane emissions. That's not really a comprehensive listing, but it certainly gives you an indication of the range of sources that do apply. So what I've created here is a diagram that tries to show what the different technologies that are being used to measure emissions are. And I guess one of the key things to note is most of these measurement techniques are spot checks, or they're point-in-time measurements that are being performed to determine emissions at a specific location for a particular source and for a particular set of circumstances. Under the emerging regulations that are existing in Canada and the United States and even in the EU, it's becoming more prescriptive. There's requirements to apply minimum measurement technologies. There's requirements to undertake measurements at regular intervals. And there's rules around exactly what sources are being targeted and what the performance expectations are for those particular sources. But anyways, the key is that the regulations are requiring operators to perform on-site measurements, and the purpose of that is to quantify the amount of emissions that are being emitted from the target sources and to actually provide information that allows you to identify the sources and mitigate those emissions. So the technologies that are being applied on the orange block on the left-hand side, I start off with a grouping of what are the typical detection technologies that are being used. So historically, there was area and building monitoring that was being done to monitor the level of hydrocarbons that existed in the process areas for safety reasons. There's also the operators that are working at the plant on their day-to-day rounds would typically apply principles of olfactory, visual, and audible detection of emissions. The modern leak detection programs that have been implemented in some of the regulations are now requiring operators to go beyond that. What they found was that simply using the area monitoring and the OVA approach didn't capture a lot of the material contributors of emissions. That by doing a systematic leak check where you went around with a gas detector provided much better indications of fugitive emissions. So that's where Method 21 first was developed. It actually started off at refineries, but has since been applied to the entire hydrocarbon sector. Method 21 involves using a portable handheld gas detector to systematically screen the individual components. And there's rules about how you hold the analyzer, what the performance requirements for that analyzer are, and those are all given in Method 21. More recently, the EPA issued what it calls the alternative work practice. So if you Google that term, you'll see the rules that apply to it. The alternative work practice involves using an optical gas imaging camera. So that's an IR camera that's been specifically tuned to see hydrocarbon emissions, or what it actually sees is the absorption of hydrocarbon emissions and the impact on the thermal imaging that you would see otherwise with that camera. So for the camera to actually work well, it requires good thermal contrast. So the best time to be using the camera is during the day on a warm, sunny day. It doesn't work it doesn't work nearly as well if you're doing it on an overcast day or days when it's raining. And it doesn't really work as well at nighttime either. And then that's typical of all of the technologies that are listed on this particular slide, is that every technology has its own limitations and its own strengths. So there's areas where it can be very powerful and provide a lot of benefit, but there's also applications where it doesn't perform very well at all. In terms of how emissions are quantified, it really depends on the type of source and the circumstances, but for on-site measurement programs, the key equipment that's being used typically includes, for flow measurements, a high flow sampler, which is a device that attempts to, by drawing a vacuum, draw in the sample or the emissions from a source, and based on the concentration and the sampling rate, then it can determine an actual emission rate. If it's a source where the gas is leaking from a vent or an open-ended line, then there's end-of-pipe measurement flow meters that can be applied. If it's a case where you can't actually get to the end of the pipe, and you've got an access port on the pipe, then people will use insertion probes to measure the velocity across the diameter of the pipe and use that information along with temperature readings and pressure readings to quantify the flow rate. And then more recently, there's been the ability to quantify emissions using optical techniques. So the same camera that you would use to detect leaks, you can get an add-on feature that has special software that takes the data from the camera and uses that to provide some quantification of the sources. So that works well where the components are not accessible, or where it's unsafe to access those sources. The challenge is that those particular measurements are fairly inaccurate. The typical optical gas imaging quantification feature gives an accuracy of plus or minus 40% under ideal conditions. So if it's not ideal, then it would be even worse. Whereas where you're using add-on flow meters, because you're putting it in conditions where you don't necessarily have optimum or well-developed flow profiles and optimum conditions for actually doing those measurements, the accuracies are not the same as what you're quoting on your financial accounting system. So typically you would expect plus or minus 10 to 15% accuracies on a lot of the portable measurement techniques that are being applied. If you go over to the remote measurements that are being proposed as a level 5 component of the OGMP methodologies, there's a variety of methods that are being considered and actually applied currently by different companies, and a lot of the IOCs have adopted these methods. The first approach is to use satellites. So there is a number of methane-based satellites that are able to measure methane concentrations and also have the ability to provide some quantification of the emissions when they do detect them. Aerial surveys that can either be using an airplane that has methane detectors built into it, or a UAV that can do the same thing. The airplanes, of course, are more expensive, but can cover larger areas over a shorter time period. The UAVs are typically only used to survey a single facility. There's also road-based surveys that can be done. That's where you have a vehicle that has methane and a GPS system built into it and uses wind data as well as the methane monitoring results it collects to both geolocate and quantify the sources of emissions that it detects. And there's also the use of a continuous fence line monitoring network. So if you have at least three methane sensors around the perimeter of your site, if the wind is blowing in the direction of those sensors, then you can triangulate and determine not only the XY coordinates for that source, but you can also quantify the emission rate. The ability of those types of systems is really a function of the number of monitoring systems you put into place, the sensitivity of the analyzers that you're using, and the wind conditions that you encounter at those facilities. The last method, which I really only mention it here, I don't mention it further on in the presentation, but the last method is using tracer techniques. That has been used in a number of recent studies to verify on-site measurements. The principle is fairly simple. You release a tracer gas at the facility or the target source at a known rate, and then you go far enough downwind that tracer plume has become commingled with the emissions plume from the facility. And if you know the ratio of the tracer gas to the target pollutant, in this case methane, in the plume at that monitoring location, then you can, by ratio, determine what the emission rate of the methane had to be to give you the ratio that you're seeing in the plume. Some of the related methane standards and initiatives that apply. So ISO has developed a 3-volume or 3-part standard that applies to greenhouse gas emissions. Part 1 is for quantification and reporting of greenhouse gas emissions at the enterprise level. Part 2 is for quantification, monitoring, and reporting of project-level emissions as part of an emission reduction project. And Part 3 establishes a standardized process for verification or validation of the greenhouse gas statements that are produced. The overarching principles that are applied in these standards are relevance, completeness, consistency, accuracy, transparency, and conservativeness. So it's a lot of overlap, I guess, in terms of some of the same principles you guys have been discussing over the last few days with respect to financial metering and production accounting. Why would you want to measure greenhouse gas emissions? And why is it becoming much more important? And why we're hearing about it in the news? One is to comply with related domestic regulatory requirements and to support your country's nationally determined contributions to mitigation of global greenhouse gas emissions, or your NDCs. But for those that are exporting their product, the international market is starting to develop clean fuel standards that are limiting emission intensities of the fuels and feedstocks that are being imported into their country. So Canada's doing that, the United States is doing that, and both those countries are in discussions with the EU. So there's a real driver for those that want to export their product to start to adopt some of the same standards that are being applied in those countries. The last reason is there's also an emerging methane market. In North America, there's an exchange that's been established by a company called Expansive, where they're selling what are called digital methane performance certificates. So where a company is showing that its emission intensities are less than the benchmark values, and the benchmark values are being developed based on the US EPA's national inventory. You develop, or you have the ability to create these performance certificates. So those are using a blockchain solution. They're providing end-to-end documentation of those credits, and they're being sold. And the buyers of those credits are typically the utility companies that are trying to help reduce their emission intensities by buying these types of credits. So the rest of this presentation is really just showing you some of the different measurement technologies that I'd indicated. This is a table that summarizes some of the different detection technologies that are available and evaluates them based on various criteria. Given the time limitations, what I'll do is I'll just let those that are interested go into these tables and look at them on their own from the copies of the presentation or the conference materials that they get. The current slide shows what kind of imagery you would get from using an IR camera. So if you actually click on that slide, it should There's a video built into it. I'm not sure if that will go when you click on that slide. Okay, I guess it's not. So if you go to the next slide, just provides an evaluation of the different measurement technologies that are available. One that I didn't mention is called using a calibrated bag, which is simply taking a bag of known volume and putting it over the end of a pipe and measuring the time it takes to fill that bag. It's a fairly crude method, but it's a technique that is recognized and does get used. But the more reliable methods are the other 4 that are shown to the right of that. Next slide, please. I'll skip over that. This is, go to the next slide. This is the high flow sampler that is sometimes used to measure emissions from fugitive equipment leaks. So it basically, as I mentioned earlier, it tries to capture all the leakage from the leakage point and then quantifies it based on the sampling rate of the high flow sampler and the concentration it sees in that. Next slide, please. This just shows if you're doing velocity profiles in a pipe, there are standards that actually establish how you would do those types of measurements, how many points you would do the measurements at. And this US EPA method 1A. Next slide, please. This just summarizes the fact that there is a quantification technique that can be used with the IR cameras. That's about a $20,000 addition to the cost of a camera, so it's not a low-cost solution. Next slide, please. This is just an example of an end-of-pipe solution. So here it's an ultrasonic flow meter that's been put on what we would call a flow cell to help promote good flow development in the measurement cell. There's actually a flow straightener in there that you don't see, but it actually makes a big impact on the reliability of the results that come out of it. But just one of many types of end-of-pipe solutions that are available to use for various types of circumstances that come up. Next slide, please, and skip past that. So this table just provides a comparison of the different remote monitoring techniques that are available, some of their strengths and weaknesses. And next slide. This is actually what the remote monitoring system, or the road-based monitoring system looks like. So here you see a vehicle with it's a wind anemometer mounted on the roof and a sample line that comes down from that and a GPS. Then the analyzers are in the back. And if you go to the next slide, that shows the kind of results that you get from that solution. It plots what you would call a curtain plot. That's the blue spikes that you see along the path that was driven, and then the program geolocates the source that would have produced those emissions and tells you what the emission rate for that is. Then the last is the satellites. Some of these are publicly, or at least the data from some of these are publicly available, like the Sentinel-5P satellite. That information you can download and use to see where the hot spots are regionally. And GHGSat actually provides much better resolution and can provide resolution down to the individual facility level. The issue with some of these satellites is that they don't work well as you go to northern latitudes. They don't work well over water. They don't work well on cloudy periods. There's actually a really narrow strip where they perform particularly well, and that happens to be North Africa and the Middle East. And then continuous methane monitoring. There was a study that was done recently that identified that the effectiveness of this particular solution is really how you design it. The ability to detect leaks can be anywhere from 10 to 90%, depending on how many monitoring points you put at your facility. And they found that in general, they were seeing either less than 1 hour or up to days before you would actually detect a particular leak. So that's all a function of, again, the design of your monitoring network, the elevation of the sources of the emissions, and the meteorological conditions at these sites. So anyways, thank you. That's a quick run through of a lot of the different technologies that apply to methane emissions monitoring and measurement.
Thank you very much, Mr. Picard. Basically, you took us through the different technologies used to achieve measurement of methane. So, if I would have a question later on, is the why is why we need to measure methane gas, and certainly when that question is asked, we'll also want to know a little bit more about the legal and commercial implication of those measurements. So moving forward, please help me welcome our next speaker, Engineer Jennis. Anyanwu is the Assistant Director of Gas Production and Utilization in UPRC. He's going to be talking about enhancing flare gas combustion efficiency. Oh, sorry, I take that back. Accounting for gas production to minimize greenhouse gas emissions and maximum value. Engineer Jennis, please help us punch this out in about 12. Let's prove them wrong that engineers can actually deliver these things on time. Thank you so much. 12 minutes, please.
Okay, I hope I can do that.
Yes.
Okay, great. So what I'm going to do, I think the conference is far gone. We've spent quite some time. And I will just try. Can you move the slides? My profile, over 20 years in the oil and gas regulatory space. I'm a registered engineer. I'm a lead ISO 14001 certified auditor. And I am happily married with 4 kids. The rest you would see on the screen. Well, from the commission, next slide, please. I just want us to look at what is the mission of NUPRC, that is the commission, and that is to promote sustainable value creation from Nigeria's petroleum resources for shared prosperity. And that fully aligns with the subject that I'm presenting, which is maximizing value through hydrocarbon accounting and minimizing greenhouse gas emission. So how do we, as a commission, try to maximize value? But let's set the context. The next slide. When you look at greenhouse gas emissions or methane emissions in general, Africa is actually not doing that much in terms of emissions. So what you see on the screen shows that the contribution, Africa's contribution is just about 3.8% of global methane emission. So Africa as a whole isn't quite contributing, right? The developed world is actually the culprit. They are responsible, more responsible for the emissions of methane. And further down on that chart, you'll see that even in Africa, Nigeria contributes just about 7.6%. And then you move down, you'll see that right? Nigeria's share in Africa is just about 7.6%, and then Nigeria compared to the rest of the world is 0.023%. So contribution of methane emissions globally from Nigeria is more or less insignificant, right? Meaning that even if we continue to do our oil and gas business, it is not going to break anything. However, we are responsible citizens of the world. And that means we must also try to exploit the natural resource that we have in a more responsible and sustainable manner. So in spite of the statistics that I have shown, Nigeria is committed to improving its environmental credentials, and the Commission is taking lead in that space. I want us to go to the next slide. So what you see here is that even when you come to Nigeria, the oil and gas isn't the highest culprit. Oil and gas contribute just about 11%. Power contributes more, 27%. Transport, 24%. And that's because those are also the burn fossil fuel, isn't it? The burn. But oil and gas activity in itself, standing alone, contribute just about 11%. And don't take my word for it. This is actually Nigeria's energy transition plan data, and you can't really controvert it, right? Now, we are actually, as a nation, have committed to achieving net zero by 2060. Now, net zero again, because some persons misconstrue that to mean zero emission. Please, that is not what it means. Net zero, the chairman, in his opening remarks, talked about carbon neutrality, right? So it is when you do the plus and the minus that you have the net zero, meaning if you emit, also try to see how to do what? Withdraw. So it is not about don't burn fossil fuel. It's about if you burn fossil fuel, also try to capture it and put it in the sink. The sink can be carbon capture storage, or you plant the trees and all whatnot. So whatever method that a country uses to net out its emission to achieve net zero, that is what we're talking about. And that is why for us as a nation, gas is the choice fuel in this our transition journey. If you look at the screen, we have legal mandates that enables us to achieve, or to see to it that we actually administer the upstream industry in a sustainable manner. The PIA is a watershed when it comes to the laws guiding, the operations of oil and gas, upstream oil and gas. And you could see a number of sections from the PIA that actually mandates the Commission to enforce a sustainable environmental management and administration in the operations of the oil and gas industries. But I'd like to mention sections 104 to 108 that speaks directly about the requirement to establish a gas flare utilization and monetization plan by all the companies. And then the other one is the compulsory installation of flare meters, and that's 106. And then the commitments that we have, COP27, the Paris Agreement 2015, these are all the drivers for moving the regulator, the Commission to be, or to drive the industry where we need to be. In the next slide, please. We also have regulatory frameworks that helps us. So because the Commission understands the need to optimize its regulatory activity, so we have the 2018 gas flare regulation, which actually penalizes gas flaring. However, just recently, the need to integrate not just flaring, but also venting, that regulation was amended, and we have a new regulation that is called Gas Flaring, Venting, Methane Emissions, Prevention of Pollution and Waste Regulations 2023. That is to show the proactive approach the Commission has taken to not only focus on gas flaring, but also to pay attention to the vented gas. And I'm going to be talking about, along the line, the so-called unaccounted gas that has been spoken about, because there is actually an unaccounted gas in the upstream sector. And I'm going to talk a little bit about that later on. The next slide, please. What you see in the next slide is basically a suite of guidelines and some regulations that is helping the Commission to administer a sustainable environmental management practice in the upstream sector. So we have, like I mentioned, the gas flaring and venting and emissions regulation 2023. We also have guidelines for flare gas measurement, data management, and reporting. Very beautiful piece of guideline. You would like to see that, and you can find that on the Commission's website. And of course, the petroleum royalty regulations, which speaks about how royalty for gas is to be administered. And that involves a lot of intricate measurement systems to be able to measure gas that goes into the processing plant, and then the products that also exit the processing plant in order to actually accurately account for gas products in its entirety and for the royalties that accrues to government. Of course, we have the other one, which is the methane guidelines. And I like to say, next slide, I like to say the methane guidelines is actually a huge, huge guideline. It was launched in COP27 in Egypt during the Conference of Parties meeting, where the then Secretary of State of the United States, John Kerry, was actually the one who unveiled it. So it was a big deal, and Nigeria was reckoned as one of the first in Africa to have made out a guideline for methane mitigations management. So that is to show that the country is actually forward-thinking. And what you see on the screen, it's the royalty regulation. One key thing here is that royalty for natural gas is based on the fiscal price that is determined for the field at the measurement point, right? Now, there is also the net back or net backing, if that is an English word, of the value of the products, which comprises of the marketable natural gas, the ethane, propane, basically the components. Whatever value is derived or derivable from the gas, the market value is net back in the calculation of royalty at the measurement point. All of this cannot be achieved without sustainable measurement. The next one, please. What you see here is basically what we call the Nigerian gas dashboard, accounting for value. Now, this is where we stand, and is giving you 3 years status of the accounting performance of Nigeria upstream. So accounting starts from the reserves. Okay, so you could see 2021, 2022, 2023 gas reserves standing of the country. As of 2023, which is usually 1st January 2023, we are holding 208.83 TCF of gas, proven reserve, right? Now, our production as at August year to date, 2023, is about 7.03 BCF of gas per day. Now, this is further broken down into the various components. So we have the export, we have the domestic market, we have what we call the field or plant use, which is the usage by the companies themselves to run some of their facilities and then to push products or the crude oil or to lift in order to enhance recovery. And then we have the flare. These are all accounted for on daily basis. We get report of measurement of this data, all right? So that's again why, sometimes when people say they don't measure, it is not true. People who don't know would think these things don't happen, but they are. The next slide, please. We do not just focus on the measurements. We are also looking at the impacts of what the resources that we are extracting from the ground, right? So what you are looking at here is the bubbles are showing the cluster or the concentration of gas-based businesses. The one on the left is actually indicating that gas-based businesses is around the Niger Delta coast. Now, the reason is that you have the EPS line from Warri area to Lagos, right? And then you have all the other OB3 connections and many other gas lines, within the area. That is where you have gas-based industries clustering. The idea is that if we move forward in the future, when we will have pipelines like the AKK or the Trans-Nigeria gas pipeline that will be taking gas from the eastern region to the northern region, the clusters will begin to go up north, meaning there'll be an expansion of gas-based industries up north if that pipeline comes into play. Again, all of this is a result of proper accounting in order to establish the real condition of the market. The next slide, please. The next slide shows you basically here is an analysis of the demand situation, gas supply and demand situation for Nigeria. The NMDPRA, which is the authority, actually establishes what we call the domestic national gas demand requirement. So they tell us that this is the volume or the amount of gas that is needed in country, right? So that number is taken. But we also know our export demand. Now we now calculate based on our production what is available for the market. Based on that analysis, we notice that both to meet our export and domestic demand, we have a gap of about 4.17 BCF per day of gas every day. So this shows opportunity to increase production in order to meet this need. Next slide, please. The next slide is basically the trigger. Earlier today or yesterday, there was a talk about the domestic gas delivery obligation. So like I mentioned again, if the authority gives us what we call the demand, meaning they do an assessment of gas needs within the country, that number is given to us meaning the commission. The commission would look at the facilities and infrastructure and gas reserves and production capacities of the upstream companies. And then there is an algorithm to allocate volumes, which is required to be supplied to the domestic market by those upstream companies. The idea is that because we're in the decade of gas, Nigeria does not want gas to simply be a rent commodity where we just export gas without value. But Nigeria wants to create value in country, and the only way to do that is to have deepening of utilization within the country. And we make the companies to supply a certain amount based on the criteria to the domestic market. Next slide, please. Yeah, so basically, the basis for that supply is their reserve, and there's a categorization of the reserves that would be required for them to bring gas to the domestic market. Next slide. Here shows that allocation formula is a function of the reserves, production, flaring, and utilization. So how do we achieve that if there is no proper accounting? Okay, because here we're talking about accounting. So it is proper accounting of the reserves, of the production, and then the flaring and what is being utilized that is factoring in determining what is the domestic gas delivery obligation. Next slide, please. Again, a study shows that by 2030, if Nigeria continues business as usual without any serious intervention to increase production or development and production of gas resources, we're going to be in short supply of about 3 BCF of gas per day. And that's because we know that there is Train 7, Train 8 of LNG, right? And there is also the AKK pipeline. There is the Trans-Sahara gas pipeline to Algeria. There is also the NCIA pipeline to Morocco via the coastal region. All of these require gas. And the population grows, and the GDP of the country depends on energy. Without gas, we can't drive that. So by 2030, if we remain business as usual, we're going to be in short supply of about 3.1 BCF of gas. And that was how the decade of gas was born, to create an intervention that will help us to close this gap. Next slide, please. So what do we do in order to ensure proper accounting? Enforce installation of flare and vent meters. That's a compulsory requirement. And we audit the measurement systems during the design and then even installation. And then we also have requirements for calibration. Next slide, please. Of course, there's also a requirement for greenhouse gas reporting. So the methane emission guidelines that I talked about has the requirement for greenhouse gas reporting. It has mandate for methane leakage detection and repair, LDAR. It has requirement for flare management, and of course for reporting of gas that is produced, utilized, and flared on daily and monthly basis. Next slide, please. Now, so what you see here is actually a diagram in the guidelines for measurement of flare monitoring. So this guideline is open to the industry. Everybody has it. It's a guideline that specifies the exact locations that meters will be placed on your facility. So if you look at the vessel you see, there are 2 vessels there. They are the separators. So when your gas comes from the well, it goes to the separators that knocks off water, gas, and crude, depending on whether it's 2-phase or maybe 3-phase separator. But in any case, the gas has to be measured. So when you look at that diagram, you see A1 and A2. Those are called production meters, measuring the gas that is produced, all right? Now, it goes into a header, all right? The A1 and A2 goes into a header. Now, if you look, that header might now go to the flare, which is the G, okay? It might also go to the E and F, which is to export or whatever. Now, did you notice that the G has the color of orange, and that's a physical meter? So gas that goes to the flare is a physical meter. But did you notice there is a H? That hedge is after the blues, you see, those Bs are on use, all right? Gas that is used for reinjection or for fuel or for whatever purpose. But the D are some dropout, or maybe what we call shrinkage in some cases. But did you notice that there is an H? That is the unaccounted gas. So all gas that is not captured as flare, or that is not captured as fuel gas, or that is not captured as export or utilization is unaccounted for. But you know what? They pay for it. It is paid as if it is flare. So that is an incentive to minimize wastage. And so we are talking about maximizing accounting to minimize venting, is it not? So that hedge is even paid for. And this is a guideline that is, this diagram you see here is in the guideline that I talked about, and you can find it in our website. Next slide. I had talked about it. So move to the next slide. So in terms of the meters, there are factors that determine what meters is allowed, and it's in our guidelines. But part of it will be the composition of the gas, the required accuracy or error, the measurement range, the calibration frequency, the data storage and retrieval requirements. Now, for production meters and FESCO meters, the commission requires a 3% plus or minus accuracy. And allocation meters is 5% accuracy. So again, this is to ensure, by the way, the production and FESCO meters, which includes the flare, used to be 5%. But over the years, it's been made more stringent in order to increase, the accuracy and reduce or minimize wastage. Next slide. And that has led us to what you see here. This is a 2012 to 2022 chart that shows the reduction of flaring over the years. And if you notice, there is a line in 2018, and that was when the regulation for gas flaring that penalizes gas flares came on board, and that helped to drive down more of the gas flares because companies began to install gas capture technologies and utilization. Next slide, please. I think that would be next slide. Okay, great. Now, this is about the unaccounted gas. So if you look at this equation, it is now, mind you, this is upstream, producers unaccounted / vent gas. In a case where, so there is a B. A is the associated gas. The B is the shrinkage factor. So the idea is you apply a shrinkage factor on the associated gas, all right? Because down the line of your measurement, downstream your measurement point, there might be dropout of the liquid. So ab initio, you will apply the shrinkage factor, which takes care of those dropout. Now, if you now have your gas, which is your AB in this case, you take out all of the consumption, the utilization, and the flare. Whatever is left is what? Unaccounted. And that is gas that is vented. We needed to just mention this. Next slide, please. Now, apart from the gas measurement or that is reported, the commission carries out a validation of the entire process. Now, there is the validation of own consumption. So when a company says, I utilize so volume of gas for my fuel, we demand the OEM data sheet that will say, what is this capacity of that generator, for instance? What is the fuel consumption as per the design, all right? What is the efficiency? And of course, there will be a run time. How long did that facility run within the period? So when these numbers come, they are not just accepted hook, line, and sinker. There is a validation process to make sense out of it before it is accepted as, okay, this is actually the situation. And that is on one side. Then on the other side there is also the well test that is conducted on every well every month. All right? So the latest well test brings out result for the gas-oil ratio. So irrespective of the numbers that we get, if I know my oil production and I have the latest gas-oil ratio, all I need to do is apply the gas-oil ratio on the oil. oil, everybody agrees that oil is well measured, right? So if I apply my GOR, I will get the gas. So again, that is compared with what is metered and what is reported. So you can see the kind of validation process that is taking place before, in order to ensure that the accounting is proper. And that's all that you see in the whole process. So the next slide, please. So fugitive emissions. So we talked about gas flaring. So gas flaring is well measured. The companies are required to install fiscal meters. So that's not a problem. But how about unaccounted or vented gas? What are they? So it could be leaks through valves, flanges, or seals. It could be unplanned venting during equipment shutdowns or malfunctions. But it also includes planned coal venting. But some other times it might include incomplete combustions from flares. Do we get that? Because when flares work, sometimes the flares actually goes off and it will emit methane. But beside that, even a flare that is burning has a destruction efficiency, right? So it does not completely destroy methane. So there's still vented methane, so to speak. Those are part of the fugitive emissions or vented emissions that comes from the flare. Next slide, please. Next slide, yeah? So key parameters to keep in mind when we look at greenhouse gas that result from flaring is the methane content in percentage of the flared gas. And then we look at the destruction efficiency like I talked about. Most times, an assumption of 98% is given to the destruction efficiency. But studies have shown that sometimes it's much lower. It ranges between 91 to 95% due to conditions such as, the switch off of the flares, and some other inefficiencies of the system. So this means that in order to maximize the efficiency of flare and reduce the emission of greenhouse gas, there has to be a regular checkup and optimization of the flare system to achieve the desired value. Next slide, please. All right, so critical actions to tackle methane emissions. I think I just spoke about that. Is to ensure that the flares are always lit, ensures that they operate effectively, and then to reduce flare ultimately. Because when you reduce flare or eliminate flare, then you are also eliminating the methane emission that is associated with it. Next slide. Well, I just talked about this. This is the methane emissions and abatement guideline and the key focus area. I had mentioned that before, so I'd like to skip this. Next. The country's goal to improve on the trilemma balance. Measurement and accounting of greenhouse gas emission is mandatory. Measurement of gas flares from oil and gas activities. Measurement of carbon emissions from leakages and uncontrolled releases. These are requirements and mandate that has been issued to the producing companies. Next slide. So, proper accounting. What is the end game? It's a win-win situation for everyone. It maximizes value for all stakeholders. The Nigerian people, the investing public, the producers, and the government. It creates value for service providers. It grows the economy for better quality of life. It engenders sustainability in our oil and gas operations towards energy security. And that attracts FIDs. Because today there are lenders or financiers that would not give you money if you don't demonstrate reasonable ESG credentials. And this is part of how to do that. And ultimately, this aligns with the NUPRC mandate, which is to promote sustainable value creation for Nigeria's petroleum resources for shared prosperity. Ladies and gentlemen, that's my presentation. Thank you very much.
Thank you very much, Engineer Anyanwu. The beauty of hearing from the regulator is that they're able to give us country-specific information. To me, that's quite significant. But in a summary, we hear that there's certainly increase in demand. That means that there has to be increase in production. And that means that the possibility of increase in fugitive emissions also increases. So these things are going to, so that brings the question of efficiency. So when time comes for us to ask the questions, we'll be able to drill down for these efficiency components. What are some of the, to revisit some of these specifics on what the NUPRC is proposing and how these things are going to be measured and enforced. Again, thank you so very much, engineer. To move ahead now, I'm going to invite Rohan Chandrakant, regional sales. He's going to be talking about enhancing flare gas combustion efficiency, a crucial step towards environmental sustainability. Raman Chandrakant. I'm sorry, I hope I did not massacre your name.
Rohan is not here.
Thank you. A round of applause, please.
Good evening, everyone. Good evening, everyone. I'm Engineer Olarewaju. I'm the CEO of Daptem Engineering. Rohan is not here, so I'm going to be presenting this on his behalf. Fluenta is our partner. We've been together for over a decade, and we've actually done a lot of projects across Nigeria. So all I'm going to be talking about is to just take it up from where Engineer Jennis stopped. I'll be talking about flare optimization. Next slide. Okay. Fluenta meters offer high accuracy and possesses the widest range of operating condition when it comes to flare gas measurements. All over the world, we have more than 3,000 Fluenta meters installed across the world. Operators to meet their reporting obligation. So in terms of Nigeria, we talk about the NUPRC. We work together with them and also work with the operators as well and the regulators as well. So we have worked together with, they've worked together with us as a company, which is Daptem. And we have in Nigeria over 115 operational meters in Nigeria already. And our largest order came from Dangote Refinery, the Dangote Refinery that is in operational in Lekki, and also we have over 30 meters also in Chevron currently. So the next slide. Okay, in the olden days, normally when it comes to flare, what operators do is to the measurement of flare is optional, but today measurement of flaring is becoming, it's a regulatory obligation that needs to be fulfilled by the operators as well. So as a company, these are the things that we are doing together with our partners, Fluenta in Nigeria. So we go to the field, we install the meters, and also we ensure that they are accurate by going there regularly on a quarterly basis to take measurements, and also these measurements are sent to the regulators in order for them to ensure that they are maintaining the range of flaring so that the environment will not be polluted as well. So it now takes us to the future, which is minimizing the effect of flaring. So incentive based on impacts that has to do with CO2 emission and hydrocarbon emission. Hydrocarbon taxation, flare efficiency, therefore CO2 and hydrocarbon emission calculated in the plant's process data. The next slide. So when we talk about flare optimization, we talk about the methane as a problem because, like Engineer Jennis said the other time, some of these methane escape. So when you think you're actually burning all the flare gas, you still have some of it that escape. And then when the flame goes off, also you have some of it escape as well. So flare do not burn all the methane in the flare stack. It is assumed to be 98% efficient, leaving 2% of the methane to be released into the environment. Using this number, the World Bank estimates equivalent of 400 million tons of CO2 was released in 2021. And CO2 is much more harmful greenhouse gas than, methane is much more harmful than CO2. So reducing methane emission by 30% from 2020 level would reduce warming by 0.2 degrees Celsius. And in the next slide, you have the CO2 versus methane warming and cooling potential. The next slide talks about what we're talking about, flare optimization, methane emission monitoring, and the 5% that are not being measured, which is actually harmful to the environment. So a more accurate approach that we as a company, as Fluenta and as Daptem, what we're trying to do is we are now working alongside industry partner to produce FlareSense. So FlareSense is the name of the product we are introducing to the market. As a leader in the heart of flare gas measurements, we provide market-leading accuracy. We are actively seeking a test site for the first implementation, offering generous discounts in exchange for ability to run a case study and receive endorsements. The aim is to take data from around the plant, including our meter, a third-party meter, and provide real-time process-related information, emission calculation, and a route future suggestion and automation that you need to reduce flare volume and methane emission. Okay, so let me define flare optimization. The next slide. Okay. Flare regulation assumes a 98% combustion efficiency to calculate taxation level. Fluenta FlareSense, which is the product we are introducing, will take data from this our meter on a on-site gas chromatograph and wind speed sensor to initially provide emission data and eventually provide the calculated combustion efficiency. So in the future, combustion efficiency can also be significantly improved through the blending of fuel gas and the stem. We can also interface with those flow control valves to automate the optimization of the flare. And that's another product called Active Flare. Also act as repository for flare meter data and diagnosis, as well as environmental reporting tool. Next slide. So from accurate sensing to active controlling of the flare. So our mission is two. We want to accurately account for this emission and also control the emission as well. So combined gas flow, pressure, temperature, gas chromatograph data to calculate the flow of each gas constituent and provide a continuous flow data. The second way we are going to do this is to calculate the emission in terms of methane and CO2 by balancing out the carbon atoms per hour and assuming 98% combustion efficiency. And the next is feature upgrade will enable a more accurate calculation of combustion efficiency, leading to less reliance on assumption and more accurate emission calculation. So on the active flare side, We're going to make use of actual combustion efficiency and other inputs to calculate and suggest amount of additional fuel and steam required to reach target combustion efficiency. This will cut down the fuel system wastage and minimize unburnt maintained emission, leading to potential lowering of the, leading to potential lower carbon penalties and taxes. Once system has been verified, automation might be incorporated to carry out the suggested actions. So these are like roadmap for us to take it up from where we are currently to a more optimized approach. So today we are looking out for partners in terms of operators, in terms of the regulators as well, to try the system, provide detailed feedback, and purchase it if there is need to. Ideal would be an onshore site which undergoes moderate flaring, then FGM 160 on site, or prepared to purchase Modbus communication and space in control room, all needed, willing to have a case written up and provide endorsements. So what we can offer to our prospective partners, that's operators, join us at the forefront of the methane emission reduction and pioneering the environmental conscious flaring, discounted product and support package, further possible partnership and opportunity on ground and local support from us. That's basically our roadmap in terms of flare optimization. Thank you very much.
Thank you very much, Mr. Ojo. That was exactly 10 minutes and 14 seconds. I really appreciate that. So it's just a continuation of what engineer was talking about, and which is efficiency. You talked about their flare sense product, which is being driven to improve efficiency through things like optimization and automation. So I think when the opportunity comes to ask questions, people will perhaps want to know a little bit more about that flare sense product and what you need to bring such an efficient system into the work. To move this on, I will call on Mr. Femi Adefala, who is the maintenance coordinator for Aradel Holdings. He's going to be talking about maintenance strategies of oil and gas measurement devices. Mr. Femi Adefala. Round of applause, please. Twelve minutes, sir.
Hello. Okay, let me have my slide, please. Okay, thank you. Good afternoon, everybody. Good afternoon, everybody. I can see that the energy level in the room is kind of low. Okay. I wish to express my profound gratitude towards the organizers of this conference, all the speakers right from day one till date. Aside that, I wish to just stand on the existing protocol. My name is Olufemi Adefala. I am representing upstream, midstream maintenance. I'm the maintenance coordinator. With over 18 years experience in construction, operations and maintenance in Aradel Holdings, I can see that from day one, all the speakers that has presented here, they've actually touched on maintenance, but slightly. And maintenance is something that is grossly undermined in our country and even in the industry. And what is the use of spending so much and in putting in place these very expensive metering devices, and at the end of the day, you decide just to leave them unattended to? That's going to cause value erosion. Okay. Now, what is maintenance itself? Maintenance itself is just all about carrying out checks, all about condition, preserving condition and situation of a particular thing that is working well. Now, even this has been highlighted in the PIA that stakeholders, operators have to account for every hydrocarbon that is being produced. Producing this hydrocarbon, it is necessary for critical measurements to be carried out by measuring devices. These measuring devices are devices that works 24/7. So definitely there's going to be tear and wear. In Aradel Holdings, we have our own maintenance strategy, which I will be sharing with you. This is something that has been working for us over the years. Next slide, please. Next slide. Yeah, just to touch a little bit on our history, though my colleague has touched on it. Aradel Energy, which is a wholly owned subsidiary of Aradel Holdings, it's a fully owned Nigerian company, and all staff are fully Nigerian, with an estimated production potential of about 15,000 barrels per day, and an installed capacity of 100 million scoff of gas. Aradel, our vision is for us to become a leading African company that is creating solutions in the energy space to support economic growth. Next slide. You know, the strategy, maintenance strategy for our metering devices has been the one of either corrective maintenance or preventive maintenance. It's either you prevent it before it happens, or when it happens, we don't really wait for it to happen before we work on our meters. So the accuracy and the efficiency of these meters, they are very, very critical. So we take our time to, we don't leave our meters alone because, and this can be attested to by the regulators who are constantly engaged in our operations, and they are always there even during our meter certification. Next slide. Metering devices in the Ogbele oil and gas integrated field, it's majorly orifice plate meters. We have the turbine meters and the PD meters. However, not to say that we don't have other meters, we do, but I just want to concentrate on these three meters. What we do in Aradel Holdings is, beginning of the year, we create a plan for quarterly fiscal gas metering validation. That plan is what we follow through. We do not miss it. This was also highlighted by my colleague when he came here. This thing is something that we take very critical. We invite the third-party vendor, the stakeholders, they come to witness it. Aside the validation that we carry out, we also have our own in-house non-intrusive inspections that we carry out every day. Next slide. Positive displacement meters. The positive displacement meters, these are meters that we use in our LACT unit at Rumekwe. We also use them at the flow station. We use that at the flow station to compare the values we get at the LACT unit at the Rumekwe end. And this has really been working for us. Please, next slide. Okay, it's okay there. Now, the PD meter, the strategy in place for the PD meter is that we have an annual certification of a prover loop system where we establish a prover-based volume. Once that is established, then with the help of the four-way diverter valve, we prove it bi-weekly with the prover loop. And that has really proven very efficient, and which is also been supported by the regulators. Next slide. This is one of our, next slide, turbine meters on our separators. These we also use in measuring liquids on our separators. These, we use them and we certify them 6 monthly, coupled with our in-house inspections. You know, the frequency of checks, next slide. At the first day of presentation, I can remember Engineer Patrick Ako made mention of all these checks. And when he made mention of these checks, I was smiling in my mind, saying that, oh, these are actually what we do. Because for us to ensure all year round accuracy and efficiency of our meters, what we do is we carry out a yearly validation of our auto samplers, our GCs, pressure gauges, densitometers, just name it. We do all of this yearly, and we do not fail. And this has proven efficient for us. Next slide. Having said all of these things, we do have challenges. And one of the challenges we have experienced is obsolescence. Yesterday, the lady that came to represent Emerson, she made mention of they are already moving away from mechanical meters, meaning that a time shall come where we'll find it very difficult to get support from them and all that. Then the orifice plates, talking about the integrity, the shapeness, and the flatness of the orifice plates, that's also a challenge for us. Then how reliable is your meters? The meter sizing relative to flow range, then the flow computer. We've had issues with our flow computers. We've had issues with the PD meters. I could remember yesterday, one of the presenters said something about they were carrying out maintenance and operation of some of these meters, and they do not even know how they function. I could remember we have once dismantled a PD meter, just trying to see if we could solve the problem, not taking into cognizance the OEM recommendation. But for now, those challenges, we've overcome them. Next slide. Our approach in solving our challenges. Now, the discrepancy assessment and checks helps ensure the reliability of the meters. When there are discrepancies, they are to be assessed and not just to be pushed aside. Continuous performance assessment of your meters, of our meters, has helped us in guaranteeing correctness, accuracy, and creating value. Next slide. Then talking about operating flow range of each meter is to be, we establish them. Then we have developed SOPs that ensure that what staff A is doing is what staff B will do in terms of maintenance. Then we also use the performance verification system of AGA 3 formula. That is the American Gas Association 3 formula, which has also proven very effective. Next slide. Yeah, recommendations. Okay. In terms of sparing philosophies for orifice plate meters, provision of adequate spares is very, very essential. The reason for this is that there has been a case where we were flowing outside the range of an orifice plate. And as at that time, by the time we went to verify, we actually noticed that the orifice plate is below the range at which we were flowing. So what the recommendation is that your sparing has to be up to date. Store enough orifice plates so that at any time you go beyond the flow range, you can take the next one. Then we have to also consider the establishment of a flow lab. This was also mentioned by Engineer Patrick Akwa yesterday. He talked about KGG having one and all that. If you cannot have one, you can collaborate with those that have one. Then in conclusion, metering devices, knowing fully well that metering devices are actually the end point of all we do in the oil and gas industry. These devices are not to be left unattended to. It is very pertinent for us to develop a maintenance strategy that would keep these devices up to date to create value. Thank you for listening.
Thank you so much, Mr. Adefala. 12 minutes and 48 seconds. I really appreciate that. Adel seems to pretty much have a whole lot of these things, and I personally am learning a lot from what you guys are doing out there. But if I would have an opportunity to ask you a question, is on the question of obsolescence. Is this something that is critical? Is this something that is rampant? And what kind of strategy do we have for that? But that will come along. So for the last presentation of the day, I'm going to call on Dr. Ken. He's going to be talking about measurement, management and reporting of greenhouse gas emissions. Dr. Ken, ladies and gentlemen.
Thank you. Good afternoon. Standing on all existing protocol. So everybody seems tired, but I'm going to awaken your consciousness. Somebody said, I hope we all are engineers, and we hope we don't die. I have some bad news for you. So when you hear bad news, people wake up. Good news is not news. So I'll be talking of Nigerian Hydrocarbon Accounting Measurement Conference today on greenhouse gas measurement, management and reporting. And before that, a little bit about myself, a word of introduction. So my name is Dr. Ken Uwalaka. I've been all over the place doing all sorts of things. So my degree was engineering, electrical, and instrumentation. And I have a postgraduate degree in environmental management. You can see where I'm coming from. Got a master's degree, MBA in the United States, and a master's in information management system and PhD in management information system. And also hold a Six Sigma Green Belt from University of Pennsylvania. While I was trying to understand the rationale behind the, excess wastage. Well, so we have to go for that training and get that certification. In terms of industry footprint, this is like my 22 years. I worked for almost all the continents in the world. I've done about 15 hydrocarbon accounting and allocation software implementation around the world. Kuwait, Saudi Arabia, Albania, United States, United Kingdom, North Sea. And interesting to know that I also work for Apple Corporation, the Silicon Valley, that delivered iPhone 8, and also work for Toyota Corporation in North America. So In all these industries, something that is standing out there that they use is petroleum byproduct to enhance their productivity. And every single day, we contribute to the environmental degradation. So if we do nothing today, there will be no future for sell your solution. There will be nowhere to do your regulation. But I'm glad that I'm speaking after the regulator, my good brother, Engineer Anyanwu. So we have to follow his footsteps to make sure that the regulation that are put in place is of great value. One of the good things the last administration did for us is to pass the PIA bill. Otherwise, we have no locus to be here talking about greenhouse gas emission and gas measurement and awarding of the first-in-class gas offtake contract. So we have a backing. So go to the first slide. Global warming. In a very simple term, it's as a long-term shift in temperature and weather patterns due to human activity. So the release of carbon dioxide and other dangerous components into the atmosphere, which in turn trap the heat that would have ordinarily dissipated into the space, thereby causing the earth and the planet to get hotter. So you see those three pictures there. This is our human activity. It is true that Nigeria contributes less than 2% of the global warming in terms of greenhouse effect. But the world is interconnected. This Atlantic Ocean that is behind us is coming all the way from United States. Whatever that happens there happens here. And it may surprise you that if we do nothing, we may be the first person or first group of nations to be consumed by that act, because they are putting a lot of mitigation in place. Right here, in every 1 inch radius in our neighborhood, we are running generator, which is fossil fuel. And we are very close to that point where the carbon dioxide is part of what we breathe in and out. So the reason why we have to pay attention to this and follow the regulator's directive and get involved. Even the metering stuff, I've been involved with a number of vendors here, right in the field, and I told them, if we don't get this thing working, we are not leaving. We're going to sleep inside this bush. Because I did not leave. If you want to leave, do what I asked you to do. Dr. Musa was aware when we are doing that on a live line. So we implemented that, and thanks to Trazim that worked with me, and they hated me so much, but they are using it today as a marketing tool. You see, they still continue to reap the fruit. So what are these components? Carbon dioxide, methane, nitrous oxide, and about 3 of them there. But these 3 are the main one that is of great concern to us. So you see, we intentionally allow gas to go into our water instead of leaking because the interest was mainly on oil. But every time you allow those gas go into the sea, what you're sending into the sea is not a dry gas. There's also traces of crude because it's wet gas. I hear unaccounted gas, unaccounted gas. If we don't start today to account for those gas, that gas will cancel us. I hope you don't want it to cancel us, right? So look at the greenhouse evolution, the global agenda, and how important it is. We have Intergovernmental Panel on Climate Change pursuing this same agenda. United States for Climate Change. It's a framework for climate change. Green Climate Fund. United Nations Environment Program change. UNISDR. World Meteorological Organization. The reason we fly safely and come down safely, and you don't say you have a very smooth flight. But what we know is that all those machines are using our products, which we here today are the front end of it, producing it. During the COVID, it was well proven that greenhouse gas emission reduced by 5.4%. You know why? Those long haul were not in the sky. And what are they using? Jet. A1. What is it? Hydrocarbon. So it was then that the people who refused to admit that this is a global pandemic started to admit that it's it's a serious issue. Factories were shut down, so emission was less. So we have every reason to say that our action today or inaction may determine if this industry will last. And we call retire in good health, like my chairman. You know, he retired and Musa, they're all in good health. We also want to retire in good health. But as technology evolves, a different method of doing things also come into play. And we don't have the way with to do with it. All what we are after is profit, money. Give me the numbers. And that's why sometimes we don't even care how much unaccounted gas has gone on accounted oil, because we believe that the one we have is enough to pay our bills. But that one that is going into the atmosphere is a big one. Here locally, we have National Biosafety Management System agencies, National Parks Services, National Agency for Great Green Wall, NOSDRA, we all know that, National Environmental Standard and Regulation Enforcement Agency, Nigerian Upstream Regulatory Commission, which is now being driven mainly on this by MMDPRA via the PIA 2021. This comes alive here. So global set goal. Experts have opined that if we do nothing, both as individual and as corporate, the world climate will rise by 2 degrees. But an agenda has been set up that we need to keep it as low as 1.5. That's the green bar you are looking at there. But where we are today, the report shows that we are coasting at 2.5 degrees centigrade. And we have 7 years to meet this deadline, 2030. Okay? So you can see how dangerous it is. And I hear most of my colleagues here, they talk about the solution they have in place. They talk about regulation. But next year, with the permission of the chairman, we need to be seeing in real-life cases how some organizations have dealt with their greenhouse gas emission, especially the fugitive gas, which we're going to talk about here in this minute. Next slide. So we have a number of legislation, both at local and international, that is driving this initiative. So we are good. Your solution, if you go to invest on it, is not going to be a waste. Go and invest on it. Go and do research. You have both global and local backings now that enable you to do all you want to do. Come to meet with the regulators, meet with the operators, and we go through these laid-down procedures. All the intercontinental partnership in climate change who are driving this around the world, we are here to make sure that we make a change when it comes to greenhouse gas emission. So what are we measuring? Where are we measuring and when are we measuring it? Go to the next slide. The question of where is the most important of it, and the grave consequences are here for us to see. There has been an increase in heat waves, droughts, floods associated with climate change. Scientists and scholars argued about 250,000 deaths across the globe every year if we are not checking this situation right now. That's not a joke. But you cannot determine which country where it's going to come from, because the world is becoming a global village. And this will put over 100 million into poverty. So you can see we are trading on a very dangerous situation, irrespective of the numbers or the percentage that is being issued out there. We have to start being part of this campaign. In 2020 alone, US recorded $1 billion worth of damages as a result of natural disaster. Our own in Nigeria here, we cannot account for it. That is the fact. Unaccounted for, right? So you may want to argue it until you go to the Niger Delta areas and see the number of cancerous patients in that location and see how the whole roof is looking. And there's no job. And he cannot re-roof those houses. And so on and so forth. The ecosystem is getting worse and worse, degraded. In 2017, it was the most costliest and deadliest in tropical storm. About $300 billion in property was damaged and 3,300 people lost their lives. What is happening? The sea level is rising. And when it rises, it also rises here. These water attributes around us here are interconnected. If it starts rising in North Sea, it starts rising here. If it starts rising in Gulf of Mexico, it starts rising here. So while we enjoy global business in oil and gas trading, we also enjoy the global disaster in oil and gas business. True of us? Good. I want us to be interactive here. In 1990, I want to set the tone before we go into what we want to discuss this evening. And I'm glad I'm the last person. Chairman said there are three people when you give them microphone, you find it difficult to take it away from them. The professors, pastors, and politicians. Unfortunately, I think I fall into one of them. So here in Nigeria, we're experiencing an unprecedented record of flooding. The whole of the Lekki Expressway. I want to bring it down home here. So while you are leaving, what Dr. Ken said here will be resonating into your ear. Who is digging those holes on the road there? The water level is high. The environment here is saturated and is easily washing away the road. And you say it doesn't concern you. Okay. You go to mechanic and change your suspension every week. Over $600 billion equivalent of the world commercial recoverable oil and gas reserves are facing high and extreme risk from more frequent storms and flood, rising sea levels and temperature at its extreme. Guess what? Arabia, Iraq, and our good Nigeria are among the oil and gas producing countries with the high risk of climate-related events. Ask me why. OPEC is made up of 11 member countries. About 40% or 30 to 20% of the crude oil output into the world come from these 11 member countries. And these 11 member countries hold more than 65% of the world proven reserves. So that's clear, right? Justified. So we are disrupting the world, even though we are small. Next slide. So let's talk about the measurement before we talk of how to manage it. There are three scrolls within the framework for greenhouse gas emission with respect to measurements. Our understanding of knowing what to measure is underpinned by these three obligations. Otherwise, that is referred as scope, as defined by IPCC. For if you are making your software development today, I've been part of that mission before. When I was delivering hydrocarbon allocation system to BP in Anchorage in Alaska, one of the success factors for that project was because they didn't give us off the shelf. We were all involved. We used what we called use cases, for those of you who are familiar with information management system delivery. Use cases where you sit with the operator or the regulator, and he goes line by line and tell you how it happened here and how it happened here. Then you go and program it and come back. We go through that iterative process until we get it right. And that is the cheapest way of acquiring a technology to support oil and gas system, which I hear from ODS and my friend here from, what's the name of that company? Frenton. So it has worked. And I can tell you, my research was why oil and gas IT project failed by 70%. Scope creep, lack of people understanding what is required because they are giving the mandate from the top and they don't want to sit down and understand what the director have asked them to do. You expect your director to also tell you how to put the key in the car. He have given you the mandate. All what you need to do your due diligence. Go back and tell him this thing you're thinking is $10,000. It's going to be 20, and this is the reason. And he will give you that money. Not when you failed and his own bosses is on top of him. Project get abandoned. They change hands over and over. And at the end of the day, it looks as if technology is not really the end thing in oil and gas business. It is the end thing. Those countries who have adopted this thing have recorded more success than us. So these three scopes, understanding that emission originates as a result of your operational activity, which is what we call anthropogenic success, the one we are creating. Exclusion of the one we are creating, the world will be cooler by almost 33 degrees centigrade. So we are highly responsible for our action. Good. Scope 2, these are emissions emerging as a result of acquisition of products and services that enable you to operate your field or assets. Example, when you purchase AGO to run your plant, electricity, purchase to run your cooling and heating system. You have acquired additional greenhouse gas emission into your existing operation facility. So when you are developing your solution, for me, I would like to see how this scope is defined in that solution. Even if it is not there today, it will be there tomorrow. Of course, there's no way to not be there. Oil and gas business is an integrated operation, so at one point you need to buy something from their neighbor. Even the meter you are bringing may also be bringing in another aspect of greenhouse gas into my environment. So you need to tell me how safe is this equipment, why it's doing this. Scope 3, the emission due to products we bought or sell to or from supplier, which we do not have control over. This is where most of the emission measurements are more challenging to measure, and this is also where most organizational greenhouse gas emissions are dependent on. Let's look at the next slide. Yeah, this is where the rubber hit the road. If you are adopting any greenhouse gas emission solution today, this is what I call the greenhouse gas measurement info stream. First, there, it's component of the greenhouse gas to measure. Have you decided what you want to do? What component are you looking for in this solution you are acquiring? Does that fit into your own operation? Every oil and gas field is unique in nature. So I don't support a generic brand when you want to deal with greenhouse gas emission. Ensure that the component that's coming from your own oil field speak to the solution you are adopting, not to do equivalent, because the equivalent in greenhouse gas measurements may give a wrong information that may subject you to litigation. I'm telling you from experience. The second step is action. What are the activities? And where is the data coming from? We have the flare, the fuel, the AGO, the gas injection, the leak, the gas leak gas systems, the venting gas, which my book regulator mentioned here, vent gas, the fugitive gas, the waste and recycle, offshore recycle. You don't know that that is also contributing. It's not only the smoke. All those biodegradable waste, you take it out, you take it to the landfill. When they decay, they emit significant amount of methane. And that is close to our own house, but it was generated offshore and disposed onshore in your backyard. And you say it doesn't matter. So you can see at the end, you have to make judgments to yourself. If the numbers we are putting today across is really representative or an estimate. Nothing wrong. I understand we need to submit national deterministic contribution, which we did in COP27. Measurement unit. Be mindful of the solution you are acquiring to ensure that the units are consistent with your own operating headquarters and local regulatory guideline. Don't go and tell Tele or Engineer Anyanwu that yes, it was in kilogram. I need to explain to you instead of carbon dioxide equivalent, metric ton. So you want him to go back and start doing conversion. He will do the conversion and put a number out there, but you will be held accountable for that, for acquiring a solution that didn't work. When you do that, the next step will be to run calculation. There are different methods that have been set up by Environmental Protection Agency of the United States, which most of the oil and gas countries in the world, sign into. And we do global and we do local adaptation. For the fuel combustion, measure fuel composition and data using what we call continuous acquisition of continuous emission monitoring method. So in that solution, you need to watch out for this when they are bringing it to you. Best available monitoring method is also there. This is usually a temporary approved method, pending acquisition of the devices. So, the regulators are always lenient to allow you to, okay, we'll give you moratorium to start from here to here, but I want to make sure that when you put in that system, we should be able to reconcile that your former method and see whether the error margin is between 0.5% or not. So emission reports, Engineer Anyanwu also mentioned that there's a standard for reporting emission. So you see, this is not a function of using Excel to do this. And if I'm Engineer Anyanwu, I will not accept any Excel report. There are reasons for that, because you need to be audited. Not just audited on that report you send, they also need to visit your facility from time to time to look at that system. When Dr. Musa was in the system, he was a strong advocate of MPMS, which every operators today have. So if I do my MER, I don't need to send him an email. The least he can do is to ask me, I've not seen your report. I say, sir, it's there. And he goes there, he pull it out, and then he give me my technical allowable. So this is my recommendation as we travel this path for the greenhouse gas emission campaign, which we are all in. We have to do something because we are dying. The world is not joking. Then, since it's subject to auditing, so you must devise a means of storing those data. And where you store it matters, either in the cloud, in the database, in your office, but it must be auditable. So if you're acquiring a solution, make sure you follow this greenhouse gas emission info stream that we are proposing. Next slide. Conventional emission plus fugitive. That will give you your total emission. We've done so well in metering our conventional gas, which Engineer Anyanwu also mentioned here. All flare points are metered. But what we have not done much is on the fugitive. According to IPCC 2026 report, 2006 report, they have argued that fugitive emission has more volume of emission compared to composite or conventional gas emission. We'll see that. So where are the sources? Engineers have talked about this, so I'll quickly go through it. Fugitive emissions from compressors, valves, flanges, seals, related equipment, process venting, evaporation losses, accidental and equipment failures, leakage from refrigerating systems around your facilities, maintain emission from wastewater, handling and sludge. My sister from Green Energy mentioned about the peak. When you recover them, it also comes with significant amount of greenhouse gas emission components. So how do you discharge them and where do you discharge them? Land disposal of solid waste. And the locations are there in your facility. So for the sake of time, I would like to go to the conventional emission, green, global warming potential, what they have discovered. So what they have said here in summary, next slide, so that my audience will follow. They've come out with a kind of factors to determine each of those components. So when you add it up to your conventional emission, that'll give you a total carbon dioxide emission and equivalent. So for oil and gas operation, measurement is highly guided by API compendium. It's not a guide for now. It was developed in 2001 and released in 2009. So they picked up everything that all the international bodies that are looking after climate change and put them together and adopted it and applied it in the oil and gas. So today, the official approved body for greenhouse gas emission reporting is IPCC. So go to next slide. Okay, so this is an example of what they have decided to do. For the oil and gas operation, measurement is highly guided by API compendium, which I said before, in line with IPCC guideline. So they've come out with greenhouse gas emission sources and the estimated formula for calculating the global warming potential. These are factors that in each of these, when you measure your fuel gas combustion, which is part of the fugitive, that formula there will give you a factor you are going to use to arrive at the right value. Same apply for the liquid fuel. For flaring, CO2 emission, flaring, maintain emission, venting, CO2 emission, and venting, maintain emission, as well as the fugitive. So the definition of all those formulas there is what you see on the right side of your screen. Next slide. Let's look at the way IPCC analyzed this. So the greenhouse emission by IPCC 2006 was based on the fact that emission source is a function of emission activity. That is to say, emission activity multiplied by emission factor. Then you arrived at the total carbon dioxide equivalent. So in this sector, they've come with a code. For the oil and gas, they grouped it into crude oil and natural gas. Within the crude oil, they come out with a factor, emission factor, for venting, flaring, and fugitive, as you can see there. So this you can find in any of the IPCC website. For the venting, they come out with the same factors for the natural gas. Next slide. So you look at this particular API compendium of greenhouse gas emission. Where is this fugitive gas coming from? Your turbine compressors. They emit gas. You don't measure it. Your gas turbine generator, they emit gas, fugitive gas. You don't measure it. Your diesel power generation system in the field, you don't measure it. Compressors, you don't measure it. And compressors become so handy now that we are signing gas contracts, because you need the gas compressor to be able to bring the export gas pressure to the point where the off-taker is going to take it, because at that current condition, it will not be able to get to export gas location. So the compressor have to boost the pressure. And as you're driving the pressure up and revving it up, your fossil fuel emission will be on the increase. Okay. Gas turbine, diesel, fuel generator. How about the crane, pumps in the fields? Some of them are equipped with a kind of pneumatic system that they meet this. Next slide. So I will come out with this. Yeah, this one. So this is a comprehensive oil field that account for whether you are doing subsea, whether you are doing surface operation, whether you are doing offloading, whether you are doing gas injection, water injection. So as you see, there are about 11 flare points in this process diagram. But there are over 300 points of fugitive emission. These are the locations where you have the pumps, the compressors, the scrubbers, and name it. So many, including the test and production separators. By the time you are clocking in and clocking out a well from production separator line to test separator line, we all has been there. We know that something goes out in between. It goes to the atmosphere. So that is to show you how big this issue is. So measurement divergence. So just next slide, I pay attention to those three places I circled. IPCC guideline is of the position that flaring contribute less of carbon dioxide. And then API, that oil and gas, says flaring is major contributor. But they say that the fugitive gas, fugitive emission is high. And then the oil and gas industries are saying that it's just 0.8 carbon dioxide equivalent. So this is where the divergence comes in. Unfortunately, API compendium method estimates greenhouse gas emission from gas flaring, which is higher than what the fugitive gas is, and is in opposition with the result of IPCC method. So next slide, let's see the journey. I have two more slides before we go. Mr. Chairman, please. You see, this greenhouse effect started as far back as 1896, and nobody was paying attention to it until IPCC was formed. They issued their first assessment in 1995, and then they had the first United Conference on Climate Change in Berlin, 1997. In all this, nothing serious was coming out from this organization. The first time they hit target was the Kyoto Protocol that happened in Japan, and that's COP3 in 2001. Then we have the IPCC issued the third report sometime in 2005, and then fourth assessment in 2007. The Copenhagen Conference failed to reach an agreement on who's going to continue where Kyoto Agreement stopped. So that was in 2009. Then they come together again, and then fifth assessment report, things started gaining traction until the Paris Agreement in 2015, which my distinguished regulators also mentioned here. And we continue. So we are now on COP27 that happened in Egypt. And COP28 is coming up in Dubai by November this year. And the whole agenda is for nations to come and review their national deterministic contribution, which Engineer Anyanwu has mentioned. Our stake, next slide. Energy sector, 60% of total emission here in Nigeria, including fugitive oil gas, and about 6% coming from transportation and power generation. What you do not see is that agriculture is also there, contributing about 25%, waste 9%, industrial process and 5%. Last slide. So, how do we manage this? In the PIA, tried to go through it many times. It seems to have met most of our problem, but there's still area, Mr. Anyanwu, maybe in your next review. What I do not see there is carbon sequestration. I don't know whether it's not a challenge for us here. But the rest of the world have come out with a technology where they send in carbon dioxide deep down inside the ground at the storage. We may not have all the uptake. I know we have a kind of in high demand of gas to give to people. But in case there's a process subset, it's good we also think about storing the carbon dioxide or the gas deep down into the Earth's surface, and then whenever we need it, we can go there to recover it and use it for other purposes. Another thing again is alternative energy or renewable energy for offshore operations. Where is the wind most apart from the desert? It's offshore. Why not we start thinking about putting a wind turbine and thereby minimizing the fossil fuel? So that's fall under my recommendation. So importantly, I also want to suggest, if it's not there, inclusion of greenhouse gas and decarbonization policy in all business proposal by both operators and service companies. I remember at the beginning when we started talking about corporate social responsibility in the oil and gas industry, a lot of companies, we are backtracking on it. But today, even the least formed companies will first show you their corporate social responsibility. Whether they do it or not is another game. So I want to create indulgence of my regulators here to see that every contract that is coming through your table, you need to look for that line that speak on corporate social responsibilities, again, greenhouse gas emission plan in this project you are going to do, and make sure you follow it seriously to ensure that we save the earth. On the interim, development of gas storage, we shall be part of your development plan. So if you are going to request for FDP or going for FID, again, I also plead from you again, Engineer Anyanwu, also ensure that every FDP that is coming to you, you need to ask for that. Where is your greenhouse gas emission plan? Because while the drilling is going on, a lot of mess goes up into the field. All the brimes, all the chemicals that you use to do your drilling operations, sometimes you dump into the sea. We all know what we are talking about here. Nobody's going to say it's not true. But we need to tell ourselves the truth if we must solve this problem, because it's a concern. One thing you need to take away from this meeting today, have you ever wondered why you turn on your AC for 22 hours? Just 1 hour you put it off. The whole house gets charged up. Ideally, you're supposed to have host or store the cooling system for at least for the next 5 hours. And you're busy running your ACs and compressors are venting. And we are saying that we are not too in the danger zone. Friends, we are in the danger zone more than the people you think they are. Because they already put up a mitigation plan. And the regulation there is tighter. For those who think that Nigerian regulators are being strict, they are not. When you walk in the North Sea, walk in the United States, then you will see, you will account for every single chemical you take to the field when you finish. The one you use, the one you did not use, and any difference, and they will come to do environmental impact assessment post-operation and to determine if the state of the water bodies before you go in remain the same. And if you're found guilty, man, prison is just an understatement. It's not just paying fine. All right? So for us in this industry to survive, because we are always in the forefront, we are the first person to inhale the gas. We are the first person to inhale the hydrogen sulfide. We are the first person to take up the methane once it is released. Whether pilots, flare, or whatever you call it. A typical example is a man who works in the sea as a sailor. When he retires, he never have a balanced movement because the rocking of the vessel had made him think that the world is rocking. When he comes out, he'll be darling. Friends, let us find the unaccounted gas before he cancels us. Thank you. I yield.
Dr. Ken, ladies and gentlemen, a round of applause for him. You can see how, you can just see how passionate the man is about the issues of greenhouse gas situation. And the fact of the matter is that no matter what it is, regardless of what we need to do, the idea of mitigation, the idea of process reevaluation, all this comes with a certain level of cost implications. So the business case is quite significant. Again, thank you so very much. I would like to go straight to the audience. If you have questions, I can reserve my own questions for later. And please be aware also that these presentations, these slides, they will be made available. So they're quite comprehensive. It's unfortunate that we have to rush through them. So we'll take as many questions as they allow us to take. Mr. MC? No, we'll take about 4, please. We have many people that wants to ask. Go ahead, sir.
Thank you very much, presenters. My name is Tele Moses again. I sincerely appreciate this session. It's been a very robust one, as far as I'm concerned, one of the most robust. I wanted to ask Mr. Jennis, who made presentation from NUPRC until the last presenter came up, and I realized that rather than asking, let me make some comments first. So one, the entire presentation by Dr. Ken was a great one, but from a perspective of an oil-producing and oil-exporting country and a member of the GECF, I do not believe that we are going to be part of pushing this global agenda of saying that fossil fuels are bad. Because of United Nations Sustainable Development Goal number 1 and number 7. We cannot accept the global north to continue to tell us that we that are contributing 0.41% of GHG emission should do something about it. We will not. Research have shown that 8 countries, 8 nations in the world contribute 63% of carbon dioxide emission. US being China number 1, contributing some 28%, US contributing 18%, and the rest. UN, the people pushing the IPCC, of course, EU 27 is contributing some 6% also. What is Nigeria contributing? He also made reference to, I'm sure that Dr. Ken will be happy for me to remind him that OPEC has 13 member countries, currently not 11, that again has total reserve of 80% of world reserve. The total greenhouse gas emission from 1914 to 2021 of all the 13 member countries is not up to even US for 1 year. So what are we talking about? Let us go and preach, and I want to speak like Ken, what's his name again? As president of one of these Eastern...
Are you a pastor?
No, sir.
Then make your point.
Okay, sir. So I think...
You mean Professor Lumumba?
No, not him. President of one of the Eastern countries, East Africa. Okay, yeah. So I think the issue of, think about it. If Nigeria stopped oil and gas production completely, the world will, and then you see this 0.1% of GHG, or 0.41% GHG emitted by Nigeria is from all anthropogenic activities, oil and gas, agriculture, everything. So if Nigeria ceased to exist or stop oil and gas operation, 0.41% of GHG in the world in 1 year will stop. 99.61% will continue. What is that about? So I disagree personally that we will dissipate the issue of energy security for our people in a bid to pursue cleaner energies that have very less energy intensity. How much can solar power, how much can it contribute? We are talking about sustainable development. We are talking about enhancing there are people from the first industrial revolution till today, they are not aware that there's anything cooking gas you are talking about. They are still burning.
Engineer, your point is, you made your point.
Thank you very much, sir.
Very clear. Thank you very much.
My question then, sir, will be how do we measure methane emissions from agricultural sector as against, we know that fugitive emissions from gas, we can put meters, we can do this. How do you quantify methane emissions for all these? He described this one that they are dissipating from other sectors and enteric fermentation and all of that. How do you measure it?
Thank you so much. Next, right behind you.
All right, thank you. My name is Lazarus Musa. It's like we have a lot of Musas in the house. Well, I wouldn't want to think Dr. Ken meant we shouldn't produce. But I'm sure he's trying to make us understand, hey, you can still do something about this. You can still reduce it. Because as far as I'm concerned, the example he gave, on your AC now, shut down for the next 1 hour, everywhere heats up. But I don't think we should just overlook such statements. But this is my question to Dr. Anyanwu, right? Okay. In one of the charts you showed, you talked about the H representing unaccounted gas. Question, how much do you expect the culprits to pay? Then secondly, in one of that charts you showed, when the regulation was brought in, you said 2018 or 2019, I couldn't get that one very well. I saw the chart. It was actually going down, but if you ask me, I would have thought by 2022, the chart is supposed to go down. Why is it not going down? Is it because your charges per scoff of gas emitted is not much enough to give the perpetrators a concern? Because if what you're charging them is something little, I can as well decide to pay that penalty and rest. But if the penalty is huge, okay, Dr. Ken was saying if they carry out an impact assessment test after you go on a job in the North Sea and you are found wanting, it's even beyond jail. You're going to pay seriously for it. Now, what are we as regulators thinking in this area? I feel the penalty is a bit light. That is why that chart shows that the thing is still hanging. It's not going down. Means nothing. Nobody is actually doing much. That's my own opinion. So what will you do in situations like that? Thank you very much.
Okay. All right, Chair, we have 2 more questions. If you don't mind, can we take the woman?
I do not mind at all.
Okay.
You want me to say I mind?
Director from Revenue Allocation.
Thank you, Mr. Chairman. My question is a direct one. The PIA made provision for the gas flare penalty to be directed to the midstream and downstream gas infrastructure fund, I think, if I'm not mistaken. Now, the question is, do you have any mechanism in place to monitor how the funds are utilized? I understand they are to be used for remediation, environmental remediation. So do you have any mechanism in place to make sure we are implementing that? so that they don't end up the way other interventionist agencies end up. You don't see the money, you don't see the intervention, and nobody says anything. And the communities are always complaining. We receive complaints from all the communities. Thank you.
Okay. So there's one more person there.
All right. Yourself? Okay.
Good evening, ladies and gentlemen. I remain Bashir Umar. My questions goes to the last speaker. Based on the Kyoto Agreement that you presented on your slide, I remember the last time I read about it, there's something like carbon credits and carbon offsets. And I know there are companies that are already benefiting from these carbon credits outside this country, from the World Bank. So I want to know, is there any incentive or preparation in which if you are able to offset a certain level of greenhouse gas emitted, is there any monetary value attached to that here in Nigeria? Or is there any incentive regarding that? Because it's being done outside the country and a lot of companies are even into it currently. Thank you.
Okay. So,
Okay.
Thank you, Mr. Chairman. Good evening, everybody. Engineer Anyanwu. Sorry, Doctor. Sorry. Thank you, the last speaker. I quite enjoyed your presentation.
thank you.
My name is Engineer Uche Okpala. I work with Zella. Currently, we are serious with what you just presented. We are serious with the EAG, and then we are taking the issue around accounting for carbon dioxide equivalent, and the rest. And we've been using APA convention. There's a place you made mention of divergency in measurement, APA and IPCC. Yeah. And then in cases where we have fugitive emissions and flaring, I think they differ in those cases. Yeah. By practice or by international convention, because we take it seriously, we record these things, we keep records. Which one do you prefer? Which one do you recommend that we take it to international level? Thank you very much.
All right, thank you. Let me go straight to that question. It's not me that recommends, but the only recognized body today that is determining and reporting on greenhouse gas is IPCC. But API is basically meant for oil and gas, but they have to, key into what. It's not what API reports that makes the global report. It's what IPCC reports. Okay, so it's not me, but this is what the global community, intercontinental framework on climate change, have come up to. Say, God, this is a standard they have given to us. Whether we accept it or not, that's. I take the opportunity to chairman to respond to my friend Tele. It's not whether we come to agree or not. The typical scenario I want to paint here, when COVID came, it didn't start from Nigeria. You were shut down. So whether we are producing less, but what we are saying is, let us start now to start acting. And majority of this thing I said is already in the PIA. If we want to measure, let's measure accurately. But the one we are not measuring is a big concern. That's the fugitive gas. And there's nothing wrong in telling operator to show me your greenhouse gas policy and plan in this entire project you want to do. There's nothing wrong there. When these seas start rising, there's no boundary that says Nigeria start here and Cameroon stand. It will come all the way through here. And we know, we live in the island. We are living in a reclaimed land. Remember when tsunami happened in Japan? Whether you believe it or not, even minister was involved. They were wiped out. And this sea level is rising. The global temperature is rising. It is not us. They create this situation, but impact us. But in our own way, let me tell you,
while we are not on that level, if these present governments do what they want to do, industrialization comes with a high level of gas emission. We don't have factories. Put 10 factories in Lagos, put 1, 2 in Abuja. It's finding that it's not only the oil and gas. The more you got industrialized, the more you feel this heat. It's not because of the oil we are producing, but for now, that is the only instrument they have found in this part of the world that is adding that 1% here. But we need to guide it. But if you want to be like them, well, I prefer you industrialize this country and let people have jobs than let individually fight for his survival with greenhouse gas emission. Thank you.
Okay, thank you very much. I think it's an interesting discussion, right? And what Taylor is saying, I align to a great extent. We are an oil and gas producing nation. Now, what we say, if you listen to my presentation, and that's what we are championing, it's called transition justice. I don't know that we've heard about that term. The idea is this, that if there are nations that have emitted tons of CO2 to the atmosphere in order to become industrialized, that they should allow developing nations like Nigeria to leverage on the resources that they have for energy security. By the way, we need to be alive in order to protect the environment.
Yes.
So the major concern, please, the major concern for Nigerians is energy security. And like he rightly mentioned, there are millions that do not have access to clean cooking energy solution. They don't have access to power or electricity. And so in what we do in the commission, by the way, recently we established a new unit that is called Energy Transition and Carbon Credit Management. Now, the idea is to sustainably exploit our resources. However, if you recall, the Paris Accord, which was 2015, placed an obligation on the developed nations to channel funds, billions of dollars, to help developing nations like Nigeria and other poor countries to fight, abate, and mitigate the impact of climate change. So that will be their contribution, knowing that for them to have been where they are in terms of industrialization, they had already emitted so much. Now, let's not forget, as soon as there was the Russian-Ukraine issue, UK changed their policy on drilling of oil exploitation. Very recently, as recent as last week, the Prime Minister has moved back all their target dates. The point is, in this issue of climate change, it's also a political issue. It's a geopolitical contest. And so the point we're making as regulators, and this is, we are saying we must leverage what we have. Let's not forget that 0.41% is really insignificant. The point is, if we extinguish oil and gas activities, it's not going to make any impact on the effect of the global climate change. However, as a sustainable and what we call a diligent nation, we are also putting in place the right regulation that manages issues so that we will ensure a sustainable development. And just before the chairman takes over, let me address some of the things you mentioned. I talked about the methane emissions guideline. If you go to section 2, all the things you talked about, emissions management in FDP, is already there. Part of the problem that we have is lack of information. You know, when we don't have that information, sometimes we assume they don't exist. The point is, you do not have any FDP or work program which climate change management plan is not part of it. I am talking about the guidelines for methane emissions, which you can find on the NUPRC guideline. It's there already. All those things that you say the commission should do. Now, let me address some questions that were directed to me. The issue of the unaccounted gas. Someone asked whether how much is it or is it too small. Now, the unaccounted gas, prior to the PIA, we had a regime of gas flare payment penalty. If you were a producer of oil and gas and you were producing less than 10,000 barrels, you paid 50 cents for 1,000 cubic feet of gas that you produce. Now, if you were a producer of 10,000 barrels and more prior to PIA, you would pay $2 per 1,000 curve. Now, in the recently passed PIA and then amended regulation, the value is now $2 cutting across board. But the regulation is also is currently being worked. But the number we have is $2.50. And by the way, the $2 per 1,000 curve of gas as flare penalty, which is applied on the vented gas as well, was not an arbitrary number. It was a number that came as a result of modeling that was facilitated by World Bank Group. The idea is it was a joint system that modeled how much does it cost to put a gas utilization facility like a CHG solution. How much will it cost the OPEX and the CAPEX over time? And then how much will be enough deterrent to make a producer choose to invest on such technology? So that's how that number came about. You know, sometimes when people don't have this insight, they imagine that things work, you know, arbitrarily, but that's not the way they work. Okay. And then someone also mentioned, so I think that the fee is deterrent enough. We moved away from a time of 10 naira. There was a time it was 10 naira to $2. So you can check what it is. You know, MDGIF, which is midstream downstream infrastructure gas fund. The director was asking what is the modality. So yes, it is the payment from flare penalty, but that goes directly to the federation account. Now, it is the duty of the authority, because that is the way the PIA has structured it. The NMDPRA would apply that money for the remediation of impacted sites. Now, but that is one of the things that it does. Another thing that the midstream downstream infrastructure gas fund does is actually to de-risk. Madam was asked when I was answering her question. Is actually to de-risk the gas sector. The idea is that the fund ought to take equity in gas investment in order to unlock stranded gas and eliminate gas flaring. Now, let me tell you, some gas are being flared today because they are located in areas that are not connected to any market or domestic gas infrastructure. And they will need a pipeline to take them from their locations to the market. Now, the MDRGF fund, the midstream downstream gas, is supposed to de-risk such a situation, meaning invest in things like critical pipeline with a partnership with the private-public arrangement, such that such stranded and locked up gas can actually be brought to market, and then the flaring is being eliminated. That's one of the intendment of that fund. And then someone talked about carbon credit. I think it's the young man over there. Yes, if Pan-Ocean people were here, they would tell you that they enjoyed the CDM. Actually, I was in Norway at the time and wrote what they call the PIN, project initiation note, or something like that, or project idea note for the CDM. Now, the Kyoto Protocol brought about what we call the CDM, which is the Clean Development Mechanism, whereby, in the same manner that we're talking about right now, whereby developed nations, right, that are developed and they have emitted many emissions, are supposed to fund emission reduction projects in less developed nations like Nigeria. So they bring money from overseas, right, and fund like carbon or gas flare emission project. I'm sure Panoshan enjoyed that in the CDM era. However, the Paris Accord expired the Kyoto Protocol and brought a new arrangement whereby the developed world ought to channel fund in an arrangement and technology in an arrangement in order to assist developing nations to reduce flares. And then they can now export the credit in such product and sold to countries like the European, I think there's European Fuel Directive or something like that. There's German carbon credit and all whatnot. So those are the kind of carbon credit mechanism that we have now. CDM is expired and gone. It ended, it had an era with the Kyoto Protocol, but the Paris mechanism brought in a system that allowed individual nations and regions to actually set up their own markets, which is called voluntary market. And people can leverage on that today, including Nigeria, but part of the challenge is that nobody or many countries or many regions don't want to fund fossil fuel projects, whether they are gas or oil. That's why some of these are also a bit difficult at this time. I think I have actually answered all the questions that relate to me.
Right.
But I just want to say, in conclusion, sirs, it is energy transition justice. And for Nigeria, which our mainstay is oil and gas, we have chosen gas as our choice fuel. Now, what it only is demanded of us is to sustainably exploit and monetize our stranded gas. Much of our focus would be to do as much as we can. But if it must be a just transition, then we expect that the developed nations, including Europe and UK or the US, will not only waver when there is energy crisis in their homeland. They waver. They jettison the climate change discourse, right? But we are committed to climate change commitments that we have made, but that is to the extent that it will allow us as a nation to provide energy security for our people. And that's what our regulation is all about. Thank you very much.
Thank you so very much. Just to add quickly to both what I'm saying, part of what I do is teach energy policy at graduate school. There's no right or wrong to these things. There's the science of climate change, and it is real. And it doesn't matter whether we only contribute 0.001%. It's a global phenomenon. The oceans run across the entire world. So there's the potential for impact for us, without a doubt. So the need for mitigation is very real. But we can't do it senselessly. We can't do it at the expense of what we need for funding for our own development. But then even that is a little bit more complicated because it's a global issue. It's a global competitiveness issue. You recall that in the last couple of years, the last vice president was giving talks over the world trying to encourage the globe not to cut back investment on gas. Why? Because we want to use gas. All those trends started when countries like South Korea, the entire Western Europe started coming out with new security parameters for natural gas, started adopting gas as their transition fuel. So we're leveraging that now. And to me, that's just if we have $200 billion in our foreign reserve and all our systems are firing the way they're supposed to be firing, we won't care whether anybody wants to invest in our hydrocarbon value chain. But somehow we seem to have put ourselves at the mercy of these global trends, and these are real. So that is why I always say that when these situations are presented, it's critical to start to look critically at the business case, because at the end of the day, the hydrocarbon business is a global business. So we cannot say because we only emitted 1%, they can go to hell. you know, their own hell is, their own hell is different from our own. Our own hell. And that's just what I would contribute to that. It's been quite a robust conversation, and I appreciate it. But what I would like to do is just to give Mr. Picard about maybe a minute, if there's anything you want to add to the significance of these reasons why we need to measure these greenhouse gas emissions.
Excuse me. My experience in a lot of the work I've done is that where we've found the largest amount of emissions, and when we talk about emissions, we talk about it in terms of opportunities, not a problem, because methane has value to it. And where we find the biggest opportunities is where there's the least amount of instrumentation, which, I mean, it makes sense when you think about it, but I think this is a perfect group to be kind of reminding you of that fact that I've been to a lot of sites where the instrumentation department resists putting in more instrumentation because it increases operating costs. It's just more devices to maintain, but there is a point where you're hurting yourself by doing that. And there are what we call super emitters in the industry, and it's a matter of trying to find those super emitters and manage them. And there are practical, cost-effective ways of doing that.
Thank you very much, Mr. Picard. Mr. Ojo, last statements for you, maybe about 20 seconds. Is there anything you want to add?
Yeah, in my opinion, it's just to ensure that the regulators are following, the operators are following the regulations in terms of people who don't really have a way of, capturing or measuring their emission rates, and also there are new technologies now that can actually convert this emission or this stranded gas into utilization, commercialization, like what the NGCFP is doing. So it's also a way to make money for operators as well. Thank you.
Thank you very much. And last but not the least, Mr. Adefala, a few comments from you.
Okay. Just given the criticality of measuring devices, it's very pertinent to commit a strategic effort to maintaining and ensuring that optimal functional of the system is achieved to create maximum value.
Thank you very much. A round of applause again for our guys and for yourselves. You guys have been a wonderful audience. Thank you very much.